we have this matrix here, and you have to show that A exponent n this equals to this. Okay, given the values of n to be 1, 2, 3 and continues like that, so obviously they are natural numbers. Okay, so first of all, what you have to do, it's we start by using the values here, the values given to us. Now when this is 1, first you first have to check to see if it truly if there is truly some connection. When n equals to 1, put here n equals to 1, this goes to 0 and you have 1. 3 exponent 0 is 1. Now that means the coefficient of the matrix will be 1. Now for the entries, 2 times 1 2 plus 3 5. So obviously it works for all when you check. Now we try for 2. So when x equals to 2, when n equals to 2, so we try that. Now we wouldn't use this, so we'll use this. I will use this. So we have a exponent 2, and a exponent 2 means a times a, so matrix a times matrix a. So we repeat this matrix twice. So we have 5 negative 1 4 1 times another one, 5 negative 1 4 1. So this will be equals to the matrix 5 times 5, okay, 25. So 25, then 5 times 4 20. We come to 4 times negative 1, that will be minus 4 times positive 1, that will be plus 4. We do the same thing for here, but we take this entry now. Negative 1 times all this and positive 1 times all this. So we have negative 5 minus 1 and negative 4 plus 1. We close this. So we'll be having a square, that is a exponent 2, will be equals to, solving this, we have 21 minus 6, 24 and negative 3. If you are to put 2 into this, you get this. Okay, if we expand, simplify, you get this, but we want to show that is equal to this, so we want to create the pattern. So now, since there is a coefficient here, we try to find a common factor, okay, among all these entries, and the common factor obviously is 3. So a exponent 2 will be equals to 3, bracket open, we have 7 negative 2 8 negative 1. Is there any common factor again? Obviously no. So we do the same thing for 3. So we are done with 2, so we pick 3. So a exponent 3, the same thing, a exponent 3. So with a exponent 3, so that means we'll go again. So better take, so a times a times a. So we are, since we've already done the a exponent 2, okay, so we pick the a exponent 2, so which is already there. So 21, we pick this one, 21 negative 6, 24 negative 3. Those are the entries I will pick. So against the a, so 5 negative 1 4 1. So that will give me the same thing. We use this 5, we use 5 times all this, then 4 times all this, then we add. So we have Okay, so that will be 105, 120. Then you pick the 4 and do that. So minus 24 minus 12. Then you use this one to create the other entry. So negative 1 times all this. Okay, so we have negative 21, negative 24, positive 1, so minus 6, minus 3. Then we simplify, so we have a exponent 3, which will be equals to create, so we have 81, negative 27, 108, negative 27. We as well factorize. Okay, since we've already factored out for the first one here, we got 3. Okay, so it's better we use another factor, since we know that the factor here, in order to match this coefficient here, so we know that it will be 3, then the next one will be 9. So we continue, so we see the next factor, which will be 9. So we have 9, bracket open, this will give us 9, negative 3, 12, negative 3, bracket close. So we have this e exponent 3. Now from this we could see that 3 exponent 1, here the power is 1, okay, and here the power is 2, 3 exponent 2, and it works perfectly with this, it matches. Okay, so but how do we create a connection between this and the entries here? To better make a sound connection, okay, what we'll do is we further simplify this. So we factorize again, we factorize, so we'll have 27. So when you factor out, it will be 3. So 3 coming out, just common factors 3. So you have 3 out of this, you have 3 here, negative 1, 4 here, and negative 1. So you have this. Now you will use this to create a connection. Okay, now picking this 3, 7, the 3 and 7, we find the relation between the 3 and 7. Now 3 can't go in 7, so that means that obviously it wouldn't be only a multiplication relation, meaning the relation between them would not be multiplication only, it should be with addition. That is, 3 can go into 7 how many times? 2 times, remain 1. So it means that there is a connection, but since there is a remainder, the connection, the other remainder is affected by either plus or minus. So how we do that, how we get to know about whether it is plus or minus, is by going back to the original relation itself, the original pattern, which is the previous one. So here, so we have 7 and 9. What is the difference between 7 and 9? It's 2. So it means there is a slope. Okay, the slope, the gradient is 2. So there's a difference of 2. So, and that explains why you have 3 going into 7, you get 2 times. So there's a gradient of 2. So 2 times n. 2 times n, then here this 3 becomes the difference. So 2 times n plus 3, and you get this here. To easily get the pattern, we could have gone to taking another value for the n, meaning 4. Okay, if you take n equals to 4, you will see it clearly. Okay, but you can say I prefer going 1, 2 and just getting the factor, getting the connection. That is it. So here, So we can create now a exponent n equals 3n minus 1 bracket open. For the first one, we know we have 2 twice of n plus 3. Now we come to this -1 and -2. Okay, when we divide, what do we get? We get +2. Okay, and the +2, there is no remainder, so it's obvious that there is a connection between them. There's a connection between them, but and the remainder, there's no remainder, so that means it's +0. But when you come back, we have to go back to the previous one, the previous value here, which is -3. So -3, and we do the same thing. So -3 minus -2, and that will give us -1. So it means the slope is a -1. Okay, the gradient is -1. So we have -1, but what? N, -1n. When you pick here -3 times, when you pick this -3 times 9, you know that you get -27 straight away. So that one is just, but you see that the -3, the 3 here and 3 here, okay, they are the same. The only difference is what? Minus, and that explains also what is here as well. N, but you have minus, so -1 as a slope, so you have -n. We come to the 4 and we do the same thing, 4, and we compare with this one as well. So 4 divide this, you get 8, so it means the slope, 4 divided by 8, you get 2, so it means the slope is 2. But you go back to oh sorry, 4 goes into 8, you get 2, so that tells us that there's no remainder. So it means that obviously that one too has no addition of either a constant more than greater than 0. No, so it's just a connection of multiplication straight away. So there is no +1 +2, it's just +0 or -0. Okay, so that's what this one means. So we go back to the top here and we do 12 minus 8, and that will be 4. So the difference is 4. So you have 4. So 4 times of n. So that is it. Then we do this as well. -1 goes into this, we get 1, +1. Now here is the issue here. +1 give us no remainder, so it means it will be +0. Now when we come to this one, -3 plus -3 minus -1, that will be -2. So it means it has a slope of -2. So we know that it will be -2n. But when you put -2n there, you know that when you have -2n, so 3, putting 3 into inside this, we get -2 times 3, which will be -6. And -6, that does not satisfy, it does not satisfy our value here. Okay, it doesn't satisfy our value, so it wouldn't work. So we do the same thing for the previous one as well. -2 times 2, which will be -4. -4, when you have -4 times 3, which will give you a -12. Yes, and that does not satisfy this one as well. So it means that there is something there's something missing there. And if we had done the n equals to 4, we will have seen it clearly. But that is not, it's not also sport. You can figure it out, since you've already had 1, 2, 3 entries already. You just have to write this plus 3. Okay, so that is it, and you are okay. So when you compare, you have the same thing. All right, now with this, you have to find, you have to find a matrix B such that B square equals A. You have to find a matrix B such that B square equals A. Now, for you to get this, all you need to do is make B the subject. So in making B the subject, we square root both sides, and we get B equals A exponent half. So that means our n equals half, and we already know what n is, and you just do the substitution. So you have E exponent half equals 3 exponent half minus 1 bracket open 2 times half plus 3, okay, then another entry minus half then you have 4 times half 3 minus 2 times half, then we close. So this, when you simplify this, you have A exponent half will be equals to 3 exponent negative half bracket open 4 negative half 2 and 2. This, when you rewrite this, okay, this will be the same thing as 1 on root 3. 1 on root 3. So multiplying 1 on root 3, using 1 on root 3 to multiply all what you have, all the entries here, we'll be having A half equals 4 on root 3 negative 1, 2 on root 3, 2 on root 3, then 2 on root 3. You have this. So you have B, your B equals to the matrix of, you can simplify it as 4 root 3 on 3 minus root 3 on 6. Okay, 6. Then you have this 2 root 3 on 3, then another 2 root 3 on 3, and that is it. Thank you.